Hello, we are going to discuss how to simulate a Johnson counter. So, in the previous video, we had discussed how to simulate a ring counter. So, the advanced version of the ring counter is a Johnson counter. And this counter is also going to be a generic counter, which can be extended to any size by using the parameter size. And very importantly, it is having the inputs clock signal reset. Then it is having a output Q, it's of range data type, then local variable integer I, and it's going to be a synchronous counter. So its gated operation is going to be governed by the clock. That's become a sensitivity signal. And next we have the reset. If the reset is 0 when the clock is positive edge, then the output of the counter it's set with the initial value 000. And the Johnson counter, it's also called a switch detail ring counter. So as we know, there is a complement is introduced between the output of the last flip-flop and the output of the first flip-flop. So we have used a negation symbol over here. So this is for passing the negated output to the first flip-flop input. Then we have a for loop to perform the shifting operation. And this shifting operation is going to be starting from 0 to size minus 1. If it's a 4-bit counter, it will execute for 3 times. And as it does, the counter will shift the value and that will produce the counting sequences. Then we have sequence of end for loop and also for the always and for the alternative statements. Then we have finally end module. So this program is already compiled. So now we will go for checking the output. So I'm invoking the John underscore count module here. And here, when I select the object, I'll select only the required signal. And the required signals are for me clock, reset N, and Q. So this I'm going to add it to the wave. So that gets added here. Then when I open the wave, again, I'm setting this clock to the lower period, that is 25, and that has been rising edge. So initially, I'm going to set the reset to 0 as an active low signal. Then I select OK. So for this, if I run, I'll be able to get the initial count 000. And further, to remove the effect of the reset, we change the force from 0 to 1 for reset. So we force with one value 1. And now when we run, you will be able to see it is started producing the other sequences as well. So we'll be able to see starting from 000, then 1000, then 110, 1110, 111, 011, 0011, 001, 00, and the sequence repeats. So this gives an idea of how to simulate a Johnson counter. Thank you.